Hello, this is a presentation of proposed stormwater system improvements in the Lake Taylor neighborhood of Norfolk, Virginia. The design team is composed of 5 Virginia Tech seniors in the Biological Systems Engineering Department. The members are Katie Clatterbuck, Courtney Delamonte, Ben Malden, Grant McMillan, and Sydney Shear. The team is advised by Virginia Tech faculty members Dr. Sample and Dr. Sridhar. The team collaborated with representatives of the City of Norfolk, the Elizabeth River Project, and Wetlands Watch. The Lake Taylor neighborhood in the city of Norfolk, Virginia, has been plagued with frequent flooding and decreased water quality in Lake Taylor. The goal of this project was to design stormwater system improvements within the Lake Taylor neighborhood that will eliminate or lessen the mentioned issues. To accomplish this, we focused on reducing runoff and decreasing sediment and nutrient transport. In creating our design, we strived to consider the desires of all stakeholders. The main priority was the effectiveness of the solution with regards to achieving our goals. The design also needed to be feasible in its cost and maintenance requirements. Lastly, the location of the design needed to be on city-owned property or within existing easements, and where it can provide benefit to the stormwater system.
Our first design solution is focused around tackling the considerable drainage issues plaguing Princess Anne Park, which experiences great amounts of standing water after periods of even slight rainfall. To alleviate these issues, we recommend the placement of bioretention practices in key locations within the park, which will slow and treat the stormwater. Placing them at the bottom of this drainage area allows them to capture all of the stormwater flowing downwards and ensures they do not disturb any tree root structures. Using these drainage calculations and the standards outlined in Practice 9 of the BMP Clearinghouse 2013 Draft Design Specifications, we developed 2 bioretention cell designs catered to the specific water quality needs of the park. We can see the actual structure of these bioretention cells in our AutoCAD design drawing. A bioretention cell is a system, and the most prominent component is the vegetation. Plants can help to slow stormwater, keep it from eroding the soil with root systems, and rid it of various pollutants. We have chosen to plant swamp milkweeds and Arrow arum on the main filter bed, black-eyed Susans on the side slopes of the garden, and goldenrods in the additional ponding area. Underneath these plants are a layer of mulch, a mixed filter bed layer made to both fulfill the plant's needs and help filter and treat the runoff further, a layer of stone which prevents any polluted runoff from seeping into the groundwater, and an underdrain pipe that will carry this runoff into existing stormwater conveyance systems.
Some of the main benefits of the proposed bioretention cells in Princess Anne Park include the aesthetic appeal, educational value, decreasing flooding, improving water quality, and low maintenance. Specifically, the aesthetic appeal was targeted because several of the Lake Taylor community members had mentioned that this park wasn't very attractive and didn't get quite as many visitors as they would hope. So we have specifically selected several native flowering plants to hopefully increase the attractiveness of this park and appeal to more visitors. Additionally, we have proposed placing educational signs in the park to increase knowledge on the water quality benefits of these bioretention cells. Hopefully these can even be used by some of the neighboring schools in lessons. For a 1-inch storm, they will decrease up to 3,200 cubic feet of runoff. Additionally, for that same 1-inch storm, they will remove up to 94% of the phosphorus load and up to 95% of the nitrogen load in that runoff. These cells have been specifically designed to be low maintenance. In the first year to establish these cells, they will mostly need frequent watering and replacing any plants that are not surviving. After that first year of establishment, they only need watering and replacing plants as needed, and then periodic mulching.
Our second design solution addresses the eroded stormwater ditches that are located throughout the residential parts of the Lake Taylor community. Our team is proposing the implementation of check dams in ditches that are heavily eroded and no longer conveying stormwater in an effective manner. The main function of a check dam system is to reduce the speed of water being transported through the stormwater ditches. Check dams also provide stability to the side slopes of the ditch. They prevent high flows from eroding the ditch away, and they allow sediment caught in the flow to settle out before being transported to another larger body of water. The check dams we designed are composed of riprap and mixed stone with varying diameters ranging from 3 inches to 8 inches. By using different rock sizes, the dam will be more stable and there won't be any large holes that will allow water to bypass the structure. During the design process, we referred to the Virginia Department of Environmental Quality's Stormwater Design Specification Number 3. We have provided the CAD drawings that were created for our check dam design. In order to make sure the design can be implemented in ditches with varying characteristics, we specified important minimum and maximum dimension values based on the requirements stated in the DEQ stormwater specifications. Based on the materials chosen, the cost estimation for a single unit, which is equivalent to one check dam, is approximately $183. We believe check dams can be a low-cost solution that will reduce erosion and increase functionality of the local stormwater ditches.
While most of the details of our designs have been finalized, there is still some work to be done. Recently, it's been brought to our attention that the drainage area we found using GIS software, the highlighted blue and yellow areas in the first photo, includes sections of roadway and residential areas that, in reality, are not likely to drain into the park. Therefore, we will need to downsize our bioretention cells to accommodate only the yellow portion shown. This will, of course, affect our final cost analyses, which will need to be calculated as well. We had originally hoped to look into rainwater harvesting, or RWH, systems using out-of-service septic tanks in the area, but unfortunately did not have the time to investigate this novel idea. We'd recommend future research groups look into this idea specifically, as it generated a lot of excitement in our group and among several of our project partners. Thank you for listening, and if you have any questions, feel free to reach out to us or our project partners. Thanks.